Welcome to lesson number 3, absolute value functions and reciprocal functions. Now, today what we're going to do is learn how to solve problems where we're dealing with two absolute values in an equation. So, first thing we want to do is look at this class example number 1. Jefferson and Julia were asked to solve the equation absolute value of 2x minus 3 minus the absolute value of x plus 4 is equal to 8. So Jefferson solved the equation graphically and Julia solved the equation algebraically. So the first thing we want to do is solve this graphically. We're going to have to input it into our calculator as an absolute value function. And so I have 2x minus 3 minus the absolute value of x plus 4. And that's going to be my y1, and my y2 I'm going to set as 8. Okay, and when we graph that, we're going to get something that looks like this. I adjust my window settings so I could have the whole thing on my graph. So my window settings look like, like this. So negative 10, 20, 1, negative 10, 10, and 1. Okay, so what we want to do is find out where these lines intersect my line at positive 8. And so I'm going to look for my intersection points, and let's my first curve, my second curve, and then I'm going to guess where that's going to intersect, and I think it intersects right over here. So I have one value at x is equal to 15, and there looks like there's one in the negative, which is why I left some space here. And so let's see what that second value is. So that's my first curve, my second curve, or hold on. I'm going to have to go down to that first curve on the other side. Okay, so here it is. And I'm going to guess it's right here, so it looks like it's about negative 3. Okay, so my x values for this graph are going to be negative 3 and 15. And if I were to draw what this looks like over here, it looks something like this, a negative 3 and 15, and then it looks something like that. Okay, so that's the first way to solve it. The second way, Julia's way, is to solve it algebraically. Okay, so the first thing we need to do is figure out where our domains are. Okay, so if we were to figure out where our domains are, that's the work that is shown right here. We're using the exact same equation. So absolute value of 2x minus 3 minus the absolute value of x plus 4. And so when we're looking for the domains, all we need to think about are the 2x minus 3 and the x plus 4. And when solving for x, we're going to get a domain of negative 4 and a domain of 3 halves. Okay, so what we're actually doing is, because we have two absolute value equations, 2x minus 3 and x plus 4, when we're solving these algebraically, what we need to do is think about the positives and the negatives, right? Because we're working with absolute values. And so when we were working with only one absolute value equation, we had to figure out algebraically what the solutions were if we had a positive or a negative equation. And so we're going to have to do that again, but this time, remember, because we're working with two absolute value equations, we're going to have to do it twice, or sorry, 3 times for each one. Now I'll show you what I mean. If I have the first part of my equation, so if at my domain, my subdomain, that x is less than negative 4, so my equation is going to fall, or my solution is going to fall in 3 places. It's going to fall here on my number line, here, and then here. Okay? So the first thing we need to determine is what this is going to be. So if I have 2x minus 3, if I make both of these a negative, okay, so in this case, I'm making them both a negative. So that's negative, and that's also a negative. So 2x minus 3 is the same thing as negative 2x plus 3. And then if I make this a negative, negative x minus 4. So if I were to solve this, I'm going to find the absolute value of negative 2x plus 3 and minus negative x minus 4. Okay, I made both of these a negative. I set it equal to 8, and then I solve by adding like terms. Now, the reason this is not a solution in the subdomain is because I have x is equal to negative 1, so that actually falls over here, which means that that did not work, okay? And so and if I look at my above solutions, I know that my solutions have to be negative 3 and 15, okay? So let's look at how we'll solve the rest of this equation. Now, I was working with two negative numbers, and now I want to work with a negative number and a positive number. So the negative number I'm going to work with is this first one, 2x plus 3. And all I did was I multiplied this by negative 1. And when I multiply by negative 1, I just distribute that negative into my brackets. And I get negative 2x plus 3. And this one I'm going to leave as a positive of x plus 4. So when I work through this, I'm going to have negative 2x plus 3 minus x plus 4 is equal to 8. Negative 2x plus 3, if I distribute that, this negative sign, it's going to be negative x minus 4 is equal to 8. If I add my like terms together, I'm going to get negative 3x. Bring these to the other side, I'm going to get positive 9. But I divide by negative 3, x is equal to negative 3. Now, this works because it is a solution in the subdomain, so that is one of our solutions. And if we look up at our graph in this above equation, that was one of our solutions as well. So I had a negative and a negative, a negative and a positive. Now I have to work with two positive numbers for my absolute value. So this is going to be 2x minus 3. It's just going to stay the same, and then x plus 4. And when I solve this, I'm going to solve the same thing, absolute value of 2x minus 3 minus the absolute value of x plus 4, and that is equal to 8. So when I solve this, I'm going to have 2x minus 3, because they're both positive in this case, minus x plus 4, and that is equal to 8. 2x minus 3, distribute that negative, negative x minus 4 is equal to 8. And if I simplify this, I'm going to get x minus 7 is equal to 8 by adding my like terms. And I'll add the 7 to the other side. X is equal to 15, which is also a solution in my domain, because x is greater than 3/2 on this side. Okay? So what we're doing is we're working with multiple absolute values in one equation, and we have to find out where these solutions are occurring on this line. And so it didn't occur in this first situation, but it did occur in these second two. Okay, because these were solutions within our subdomains. And so what our subdomains were in this case was x has to be greater than or equal to negative 4, which it was, is negative 3, and less than or equal to negative 3/2, which was true. And it also had to be greater than 3/2, which was also true. Now let's look at this next example. So it's really best to start these questions by looking at your number line, or at least creating a number line. Now in this question, it's already made for you, which is really nice, and it tells you what one of the domains is it's going to fall somewhere on this side. Now your other one is going to fall somewhere in between negative 4 and 2, which means that x must be greater than or equal to negative 4, but less than or equal to 2. And then over here, you can also have an x value, which means that your x has to be greater than 2. Now we're going to do the exact same thing, where we solve two negative equations, a negative and a positive, and then a positive and a positive. In which case, our positive and positive is already done for us, and it comes up with being not true. And so you can walk through this and see why it's not true. But over here, let's start with this end here where we work with two negatives. Okay, so if I have negative x minus 4 and negative x plus 2. All I did was I distributed a negative sign across my equation. And when I solve this, I'm going to get negative x minus 4 is equal to negative x plus 2. And if I simplify this, my x is going to cancel out. I'm going to have negative 4 is equal to 2. And so that is not true, so there's no solution there, because negative 4 does not equal 2. And so I'm going to guess it has to be this one down here. And so I'm going to work with a negative and a positive. So this will be my positive x plus 4, and my negative will be down here, negative x plus 2. And when I solve this, I'm going to have x plus 4 is equal to negative x plus 2. If I am to balance this equation out, I'm going to have 2x over here by adding the x and then subtracting the 4, which is negative 2, and x is equal to negative 1. Now, if I look at where my domain is, if I have x must be greater than or equal to negative 4 but less than 2, this indeed works, so my final solution is negative 1.